Okay, so yeah, welcome everyone to the 24th edition of DevOps Kathmandu. I hope I'm not wrong in the number. So yeah, today with us we have Engin Diri, who is a developer advocate from Schwarz Group, Schwarz IT, under like Schwarz Group. So he has worked all over Europe, and he's currently residing in Germany. He's really passionate about cloud native stuffs. He has done a bunch of CI/CD, stuff with a lot of different providers and a lot of different tools. And like he's really passionate about infrastructure and all those stuff. So yeah, today he is joining us to talk about GitOps. So this can be a foundational, talk for a lot of people. And like foundationals are important. But if you want to jump ahead, if you are already like using GitOps in your deployment environment or something like that, go ahead and like suit your questions with Engin as well. So we will have some hands-on little demos at the end as well. So yeah, it's pretty exciting. So I would like extend my gratitude to Engin for joining us here today. So yeah, thank you, Engin, once again. Please go ahead.
Yeah, thanks for welcoming me. I really appreciate again this gesture. So let me share my screen, and hopefully everything works fine. No, that's you see now I start just to share the PowerPoint. So I will share my whole screen, and then we can start the slide. So okay, I close the screen. So you can see the screen. Everything works, Yankee?
Yep.
Okay. I want to talk to you about cloud native engineering with GitOps. And as this is a huge part, I just cut out a specific area of this. So without any further ado, let us start this. Come on. Okay. So just quickly about myself. So as mentioned, my name is Engin Diri. I'm working for the Schwarz Group since 2017 in the Schwarz Group. The Schwarz Group is known in Europe and in America for their retail brands Lidl and Kaufland. We are the fourth biggest retailer in the world, depends from the year to year, fourth or fifth biggest. So that's something in this area. There I mainly work in the area for cloud transformation and also enablement, so helping the internal developers and operation guys to have a successful transformation to the cloud. And I really love to continuous everything. So from continuous integration to deployment, everything is so my favorite part. I worked before, maybe I just put it for the completeness. So I worked in different places in the UK. I worked for Convergys, building some rating and billing engine for mobile phones, but also I joined the IT of Hilton, the hotel brand. And interestingly, there's much IT going on in the background of a hotel. So this was really also interesting for me. And I highly appreciate to check out also companies you would not thought about, because sometimes they have really interesting IT. So today's agenda, I just want to quickly go over the topic, what is GitOps? And now from a real life perspective, because yeah, you could watch plenty of YouTube videos, you can get additional information to have some academic view of GitOps, but I also prefer, and this is partly because of my role, to explain also why should I care? Why, for example, I'm in a company, we go some classical approaches. What is the benefit for me, the real life benefits I can take away to say, okay, if I invest this amount of time, what are the outcomes from a company side? Because that's always the big thing for my private projects and so on. That's something clear. I can install it quickly or use it and so on. Nobody's going to ask me, but in a corporate environment, we have to answer questions. And this is something I would like to help also. I want to talk about several implementations of GitOps, and then, as Yankee said, quickly going to the demo. I choose and build up a demo which is quite common. So we have also some multi-cloud scenario to say, okay, how we can, for example, use with GitOps and multi-cloud environment, and of course, also some how to build up the infrastructure, for example. And then we come to the conclusion and open questions. So that's really looking forward for this. Again, if something is unclear or I speak too quick or something, feel free to interrupt. As I said, it's not a YouTube video you just consume. That's the reason we sit together. Just to show you that this whole question of GitOps is still something I would still say fairly new. And it's not something where people are on one page and say, yeah, man, that's really the cool stuff. So I choose some tweets, some recent tweets from persons in Twitter who are very strong opinionated or have some kind of influencer status, where I say, okay, if they tweet about this, this is something I should think about. So we have Steve Smith, who's quite skeptical about the whole GitOps thing. He's really saying for him is GitOps is just a placebo, and he's having really a strong opinion against GitOps, or at least challenging this whole buzz about GitOps. So that's quite interesting. And then, of course, we have His Royal Highness Kelsey Hightower, who is really open-minded for this, and he sees GitOps really as a good thing and something we should use to handle new situations we encounter during our daily work with infrastructure and all the things in the cloud. So these are just two opinions. And again, to say this, for example, in my workplace, we recently had a bigger discussion to say, should we put GitOps in a management, in an architectural decision, to say we go with everything with GitOps? And even there we said, okay, it's fairly new and nothing is wrong to have still the other way. I mean, for example, the CI ops, to say, okay, I still use my CI CD engine to deploy the stuff, for example. Nothing is wrong with this. And let us see if we can adopt this. Let us see the challenges we have. We have also a huge movement to the GitOps. So the most parts people deploy, for example, to OpenShift or the Kubernetes in our company is using Argo CD, for example. So as you can see, it's something we have to keep in mind and see if we are ready for it, or should we prepare some things to adapt GitOps. So I will focus here on the GitOps part. I will focus on the Kubernetes thing. So when we talk about GitOps for Kubernetes, we have a specific idea behind this. So you could say, yeah, Engin, if I write my Terraform scripts, for example, this is already also GitOps. Yeah, that's for something for sure. So writing your infrastructure in a declarative form, putting it in your Git repository and executing it from certain places, this is also, you can say this is also GitOps. But there is a specific thing now with the rise and the de facto standard of Kubernetes that everybody says we use Kubernetes either directly or indirectly as a service, for example, underneath. I'm a service provider. My engine is, I want to create a SaaS service for the people to use, but my underlying engine is, for example, Kubernetes. So it makes sense to think about and to understand what does GitOps mean in a Kubernetes way. And it's a way to say, okay, how we deliver the application to our Kubernetes cluster. So in this case, I just mentioned it before, we use Git here as a single source of truth for all our declarations. So everything is written in our Git repository, the technology we're going to use. So if you use, for example, Terraform, you have your HCL files, for example, checked in. If you use Kubernetes, for example, all your declarations, the YAML manifests, they all rely in Git. So we use Git is something we as developer, we are used from our everyday work. So this is something we are like, okay, it makes sense to have everything there. We have additional features we can use in Git. We have an audit log. We have a rollback functionality. And now the funny part comes also from a enterprise part is we already adopted some kind of pull request workflows. So we have also some controlling. We have some 4IS principles. So we get also input if we do something. And this is one place we use, and this is the Git part of the whole GitOps. And the other part on the GitOps, if we're going to use it in a Kubernetes context, is, okay, we have now our Git repository where our declarative state is, and we have now a counterpart in our Kubernetes installed, a Kubernetes, a GitOps engine, a GitOps backend, and all what is doing, and it's really that simple, is the Kubernetes, the GitOps backend in the Kubernetes cluster is all the time checking the Git and looking to reconcile the states, because Kubernetes is a big state engine, a big state machine. So if we get some changes in the Git repository, the GitOps backend in the Kubernetes cluster sees there's a difference and start to reconcile this automatically. So that's the interesting part of this. So we do our processes on the Git side. Something changes from an automatic system, like automatically pushing a change, an update to an image into our Git repository. The Kubernetes backend engine, the GitOps backend engine in the Kubernetes cluster sees the differences and try to reconcile this. That's really nothing more about this. So that's the interesting part. And now there are some principles to say, okay, when do we talk about GitOps for Kubernetes? So as I said, the entire system needs to be described declaratively. That's one point to say when we talk about GitOps for Kubernetes. The desired state system is version controlled. So we have it in our Git repository. That's also very important. As soon as we approved any changes, like a pull request or something on the left side of the process, the system automatically detects it and applies the changes to the system. That's also one part. And the software agent, as I said before, ensures the correctness and reconciles any divergency. So if anything, if there's some drift, that's a big problem. If you say we have some configuration drift, or somebody manually connects to the cluster and changed the replica set, or changed anything, the agent detects this and reconciles it back to the single point of truth to the Git repository. So that's also a very interesting place. I think some people who used, for example, Ansible already know this. You had the possibility also with Ansible to run them on a quite regular schedule and to keep the configuration drift of the managed services and managed files in the Ansible, for example, always on the state I committed in my Git repository, for example. So here, this 4 points makes the whole GitOps, and this is the principle. So if you join the GitOps working group, for example, this is something you will also see. So this is not something made up, but it's really the core of the whole GitOps for Kubernetes. Okay, yeah, that's it. So I mean, when we talk about this, I always a little bit surprised to say, yeah, from a high level perspective and from the idea behind this, this is it. Of course, you will have some challenges and some questions if you go to the implementation, but from a high perspective, this is the situation. We have a system X and we have a state, and the systems is working together to achieve the declaration of the state in our Git repository. So now comes the big question. Okay, but why should I care, for example? So, hey, we have our processes in place and everything is working. So what is the real benefit? As I said before, what is the benefit, for example, in an enterprise environment to say, why should I change this? So, and this again is also some experience we had at the Schwarz group. So this is maybe not applicable to everybody, as I said, but at least for us, it was really something we had to keep in mind. So what do we have? In a classical approach, we have this CI/CD pipelines. They have a quite known way to go. So we do some changes, we build the stuff, we run our CI pipelines, and then we trigger some delivery pipelines and do the delivery there and deploy to different stages. On the right side, we have then finally our, for example, our Kubernetes. So this is the current situation, the situation we still have, for example, at the Schwarz group. So nothing here, and really something to see. So what are the things why we said, okay, is there not something better, or could we not create adopt another approach to mitigate some of the problems or some of the questions we have. So for us, again, this is the real life feedback we have. We have some quite complicated deployment pipelines. So there was going really some magic on where people injected stuff from different places, collected config and secrets and so on from different places, and we shifted the knowledge, the brain knowledge from one system to the CI system. So we have a split brain scenario where we say, okay, what happens, for example, if the CI system is not available anymore? Are we able to deploy the stuff? No, because we have so many different sources to gather the final deployment. It's really complicated. And for us, it's also something real. We have to pay or maintain our deploy agents. So we use, for example, in our place, we use Azure DevOps. So we have to pay for this hosted, Microsoft hosted agents for the pipeline runs. And for our on-premise deployments, to reach them from the network side, we still have to maintain virtual machines just running, for example, the deploy agents there. This is really also something not something every project is willing to go, and then we start to create this agent pools where somebody is offering this kind of service to the company, and there's always friction and hey, there's something missing and so on. And this is one part, so we can reduce here this operations and this tribal knowledge for the pipelines. Other thing what was for us very important for the security part was we started to drill holes in our firewalls, because the CI system or the agents, they had to have access to the specific cluster. So we had on-premise agent in specific network zones where we store, for example, our purchase data or our ordering stuff, our supply partners and so on. So they are in a specific network zone. Not everybody can enter this. And here we had to create holes and to say, yeah, but I need to access the port 6443 and all the stuff. And as you can imagine, in an enterprise environment, this is also with quite a process behind this. So we had to create and ticket, and you have to wait for this and all this stuff. What complicates it, and that's not something feasible in a very agile way. Also, what we have is that we started to store the credentials everywhere. I mean, this is maybe also some specific thing, but scattering the Kubernetes credentials, creating some service account of the Kubernetes, and using the kubeconfig, for example, saving it in a vault or saving it in some kind of a key value store. But also not something very good. They can leak. People can have access. They can have admin access to the system. You could accidentally use an agent where another project is using. You forgot to purge, for example, your kubeconfig, and voila, the persons have access, for example, to your namespace or to your cluster. So this is also something not very helpful. And yes, of course, the side effect, as I said, so if you have some shared agent or some on-premise agents who are all the time running, they are not immutable or something like this, it could lead to some leaking and to accidentally accessing somebody else's cluster or namespace and deleting, in the worst case, a deployment. The other part, what's very important on a company side, especially if you have some processes in place, is we have the full auditability of all changes. So we can now really see, for example, in our GitOps history, in our logs, we can see who approved it, where is the pull request behind it. So everything is really traceable. You can see what happened. And this is something what makes, for example, our compliance very happy to see the stuff. Yeah, you could have this also with the other part, but here it's really something obvious and very nice. And as I said before, the configuration drift is also some real thing. We had all the time situations, for example, where people connect to a machine and do some work there because something was broke or something did not work. And they forgot, for example, to mention it in the documentation and all the stuff. Here, we can, for example, do the changes. We create a pull request. We roll it out for the dev environment, for example, and everything is clear. And you don't come in a situation where you change something manually or fix something manually, but did not put it into the code, for example. So this was for us some of the questions we had, and we found that the GitOps part will solve some of them, or most of them. And how does it look now at our place? We still have a CI system on place, so we really have this big application, Azure DevOps, for example. Some other persons have a Jenkins, for example, in place. There's all the CIs going there. We create our image, for example. We build our software. We have Artifactory and all this stuff. So everything is there. But there's a place where we say, okay, from this side, we leave the CI/CD system and let the cluster do now his magic. So everything what gets delivered to specific stages and so on will now tackle from the GitOps part. So the GitOps agent is installed on most of the cluster, and the names, everything is configured. So people build a new image, for example, they tag the image, and then the system detects it. So some of the GitOps engines have a clever way to detect, for example, development tags. He automatically scans, for example, your Artifactory repository, your GitHub account, sees a new image comes in and automatically deploys it, for example, to the dev stage. And for everything else, you could create some processing, making a pull request, approving it. And here's also a place where we start now to work, is to get the biz more involved into this. So we get our business consultants into the team to build this cross-functional team and say, hey, everything goes, for example, in the pull request. So you can decide in the pull request when you approve it, because maybe the systems behind are still slow. Maybe you need to test the stuff, but you can use, for example, the pull request to start the story. So there's not the button anymore. That was the first thing that people asked, to say, hey, where is the deploy button? Where is the deploy pipeline? It's not there anymore. I don't have any control what goes to dev. No, that's not like this. If you are not completely 100% automated, and this is still the majority of people, we don't have this value chain where we submit a small feature, do all the testing and make the automatic testing and go to prod on the same day. So some businesses, they don't want this. Some businesses, they don't have the tests, for example, in the background. So they say, yeah, but I have to call the external company who do all the testing. I cannot go to prod straight. Yeah, but you could use, for example, the pull request and approve there and say that's fine. And depending on how you configure the GitOps backend and the cluster to it, it will detect and will automatically start, for example, the deployment, but you still trigger this. You don't lose full control. The best thing, of course, is when you have a story going through. So from the user story on the left side, doing the task and going completely to the productive environment, because everything is placed. You have from unit tests, you have integration tests, you have full end-to-end tests in the back, and you know there is the new functionality will work. Or I voluntarily want to roll out this new feature in some kind of a canary release to specific group of persons. So I configured this, the service is running parallel with the old service, but I have some kind of routing in place where a specific kind of person gets to the new service and gives you feedback, you collect the metrics, and you could even automatically roll back the situation. So as you see, there is much possibilities here. Okay, that was the animation with the pull request. It's quite broken. Okay. So on a short thing is to say, okay, we don't need anymore the terminal anymore. So with GitOps, we don't have this kubectl apply anymore. We don't have this Helm upgrade or Helm install parts anymore on the pipelines. So no need anymore for our terminal and for the scripts, the bash scripts who do everything on a CI ops part. I could make also a UI there and say, okay, you don't need even the UI because there's still persons who use, for example, the UI to deploy stuff. So no problem on this side. Okay, what are some implementations available? So there are, as you can imagine, there are different flavors for this whole GitOps for Kubernetes part. So let me take some of them, and I'm sure, as you know from the CNCF landscape, there's always some movement. So there are always some new application coming in, and there's a new tool. So you never really can say this is the amount of tools and now choose from it. I took some popular things and some things we worked on to give you an idea. So we have specific places for, we have specific backend, for example, Fleet by Rancher. This is really made for, I mean, we say it's GitOps on steroids. So it's really made for huge cluster management. So that's a really interesting thing. I mean, it follows the GitOps principles. There's no nothing on this side, but specifically made to say, okay, I'm not only delivering to 1, 3, 4 cluster, I'm delivering to thousands of clusters. So that's the approach of Fleet. We have Argo Cd. Argo Cd is an incubating project in the CNCF landscape. And I would say it's the body everybody needs. I mean, we tried this and we saw that the majority of people in our company, for example, they are really happy with Argo, the UI, the experience, the observability of what's going on is really, really nice in Argo. So for us, it's really the one thing you can't go wrong if you use this. It's the whole Argo project itself is meant to be a platform, so you can extend the Argo feeling for Argo events. For example, you can use Argo workflow, for example, Argo notifications, and so on. So there's really some additional parts where you can build a workflow engine with Argo workflow, and it's really nice. The Argo CD part is also here. Captain by Dynatrace. This is something I have on the screen to say, okay, when do we go, when we could try, for example, with Captain. They have some nice, interesting approaches also for this kind of progressive delivery. Argo CD has also progressive delivery, but Captain has also some nice takes and say, okay, everything is built in. And it's really something to try, for example. And then, of course, there's Flux. Flux by Weaveworks. This is really, really nice. But I would say Flux or the GitOps toolkit is a really vanilla GitOps backend. So it's not a platform like Argo CD, for example, is doing. It's really really the core principles of GitOps and as a backend. And for example, one major adopter of Flux is Azure. So if you ever have to work, for example, with Azure Arc for Kubernetes, and you want to create this, you want to put your local Kubernetes clusters, for example, into the Azure cloud with the Arc, is using Flux, for example, under the hood. So Flux 2. So they recently moved now also to Flux 2 before they were on the Flux. So that's about this part. And yeah, I would now go to the live demo, but still want to ask, so it's not really like a passive enjoyment, to ask if you have any questions so far here. Let me see the chat if there's something. Okay. Okay. If there's no question, we have later, we have also time for some questions, so that's really fine. So let us go to the demo part, say, okay, how does it work? And funny part is I use the Terraform GitOps part to spawn also this Argo GitOps part. So that's really funny. Indirectly, we can also see how to use, for example, the whole Terraform part. So what I did is the links are in the slides. You can check them out. They're on my GitHub repo. I created a GitHub repository where I say, okay, we have a control plane, and we have also this multi-clusters. These are our client clusters. We want to deliver our application. It could be a main application. It could also be parts of a bigger application. You say, okay, I go to, for example, in my on-premise cloud because I need to do stuff there, but I use, for example, a cloud provider, AWS or whatever, to use some services there. So I tried to mock this a little bit. And of course, our control plane. So I use Terraform, I use task file to write everything down, so I can execute the task file and say, please deploy the infrastructure. So this is something I can put, for example, in my CI/CD pipeline. I mean, that's the thing, I have to start somewhere. So it's a hen and egg problem. So, but there will always be one thing I need to spawn either manually or here with a classical CI/CD approach, because I have to provision the control plane. Even if you use systems like Crossplane, you have to have this bootstrap cluster, this ignition cluster to say, okay, someone has to do it. So in this case, I use a task file to execute the tasks. Inside the task file is some Terraform scripts going on, and the Terraform for the control plane is not doing something else than creating on Civo. That's a cloud provider here in Europe, mainly focused they opened now also a data center in Germany. They have a data center in the United States and in UK. So it's a cloud provider from the UK, and they offer K3s as a service. So I will create the control plane here on Civo, and I will install also the Argo CD on top of it. I created also, I mean, K3s has traffic inside inbuilt as an ingress controller. So this is something that's already there. And I use the cert manager to create the URL for Argo CD. And I will get also a certificate from Let's Encrypt, and the cert manager is doing this. So everything you see on the left side is all under the folder control plane. This is one part. And then the interesting part comes, I will use also Terraform to create our multi-cloud clusters. So I created one Kubernetes cluster in Scaleway, and I created another Kubernetes cluster in Linode, just to have some variation and say, okay, I can use Argo CD also for multi-cluster management, and this is something what becomes more and more real and more and more a valid use case scenario. And even if you have to say, as I said before, I have an on-premise installation. So on-prem is for me also some kind of cloud. And actually, we as a retailer, we have the situation. So in our stores or in our factories, we have vSphere, for example, installed. So if we need to create something like this, this on-premise multi-cloud scenario is really some use case. Okay, this is the infrastructure part. And now we come to the Argo part of the demo I will show to you. So I want to explain to you two patterns of Argo, which I found quite useful, and you will always see when you're going to work with Argo. One pattern is called the app of apps pattern. This is something you define an Argo application, Argo CD application. We will see this later in detail. And this one describes the whole application itself. So an application can consist, for example, here in this example, we have a Grafana, we have a Prometheus, and we have also some services I write on my own. So here, example, the Hello Server domain is a Go application. And to not write in Argo CD millions of little applications and put them there and say, okay, some kind of logic to say who belongs to who, we can use this app of app pattern. And this one just is a description and says this sub applications belong all to the bigger application, and it makes life so much easier. So I really can emphasize to start already with the app of app pattern. This is one part. And now we come to the part with the multi-cluster. There's also the possibility in Argo CD to use an application set. An application set has different templating engines. It's really something details I will show to you. And there you can also say, okay, I describe an application, what I want to deploy. And he will automatically multi-cluster deploy this for me and with specific scenarios. So in my case, we will see the potato head project, and this one gets automatically deployed to the specific clusters, and we will go in the code in more detail. Okay, so then let me close my PowerPoint presentation, and then we can go into the Argo CD deployment. So here is my Argo CD. That's what I said. It's on K3s. It's already deployed there. Let me close this screen here. Okay, so nothing on this side. When we see you log into the system, you can use federation and all the stuff. So there is no problem. You can use your single sign-on, your internal Active Directory, for example, your internal LDAP or your OIDC provider with your internally. But you could use also some external OIDC providers, because Argo CD brings a DEX with him, and with DEX you have the possibility to federate here. In this use case, I just use the local connection, so I have an admin user. And here you can see the clusters. As I said, I want to make the dynamic part of the multi-cluster I want to create during the demo. So you see, it's at the moment, it's just the in cluster. I mean, the Argo, the Civo cluster. I don't want to deploy any workload there for my customers. So this one does not get scheduled. And now I have the possibility to create applications. And now you can see again, even if we say everything has to be as code, it's quite easy for the people to have an idea and to say, oh, I want to play around. I click on the new app possibility. I fill out with the UI. I can fill out some stuff, but I can click on the edit as YAML and copy paste the stuff in my Git repository. So even if I don't remember the specific form on how to write the YAML for this Argo CD, I can use the UI and copy paste the stuff. And that is also one of the reasons why my colleagues, for example, really love the system, because it helps them. Not everybody has the same level, and but this is helping them to get on speed. So here we can create the application. We're not going to touch here because we want to do everything as code. And there's also the part. So let us go to our code base. As I said, here are the different folders. Here's the control plane. Here's the multi-cluster. Here's the task file I mentioned before. You see, I created different tasks, and every task does some specific part here. For example, in the control plane infrastructure, I deploy the infrastructure as a Terraform. So if we go to the control plane, to the infrastructure, here I have my Terraform description. And in the Civo part, you can see now where I create the actual Kubernetes cluster with the properties. You can put everything out into variables. That's also nice. So everything you see here, every variable is something you can put in the so-called variables files. For example, my Civo token, my API token is marked here in Terraform. If you don't fill out anything, it will prompt you during the Terraform apply, or you can set it as environmental variables. So this is different approaches to do this, so you don't need to put your code into the your secrets into the code. So here I create the cluster, and now let me also this is the infrastructure part, and now the applications I want to install on the control plane. As you can see, I use also Terraform to deploy some Helm charts and also do some Kubernetes deployment. For example, my external DNS or the cluster issuer for the cert manager. This is some things I have to do. Everything is as code. And you see here, I just access the external DNS chart. It's written here, the cert manager. I deploy a special issuer for Let's Encrypt that I get a SSL certificate, and then I deploy Argo, and so on. So nothing new on this side. If you ever used Helm, the CLI, you know the things, creating the namespaces. And what I did is also I used a values file to override some of the values. As you can see, for example, my domain is Argo Cd Deployment online. So I override this, and I say also where to find secrets. That's also one thing. External DNS, for the people who don't know the specific tools, for example, external DNS is a nice project where he detects an ingress, for example. So you created a resource ingress, and he goes to your DNS server and automatically subscribes it to the DNS server. So for example, I create here an ingress with the host name Argo Cd. I don't want to go to the UI of the DNS or want to create some kind of CLI commands, because maybe I will create another ingress. So to automate this using external DNS, detecting here the stuff, I configured external DNS to use DigitalOcean. So my DNS provider for this demo is DigitalOcean. I just provide the DigitalOcean token, and he automatically subscribe the A record to my DigitalOcean account. So that's really nice. Yeah. At the end, Argo gets deployed with the specific setting, everything fully automated. This is the whole control plane part. So as you can see, I also created the Argo CLI commands as an automated. So I put, for example, the Argo login. I get, for example, the password directly for the admin from the Kubernetes secret. And I just make the login. So the stuff is logged in, and I can continue to register my cluster. And now the fun part starts, and I really love this. Let us see the multi-cluster deployment. And again, here, nothing new on this side. We use also here Terraform, and now we have these two specific providers. So we have Linode. So we create a Linode cluster. Again, everything is configurable. And what I do is, because I need the context for the registration, I also export shortly the resource of the kube config. So the cluster gets created, and I say to him, and please take the output of the cluster, the kube config, and write it to the Linode YAML file, because I'm going to need this to register the cluster to Argo Cd. There's also different approaches, so it's not you can also use different ways to register your clusters to the Argo control plane. I choose this one, but yeah, feel free to improve or come up with your own. In this case, same goes for the scaleway. I define the scaleway cluster. All the settings, again, everything could be configurable. You can set the values as you want, and you can create 5, 10 of them, tagging them with production, with QS, and so on. So you can put a staging also there. Here for the demo, I just created 2, and they are all equal from their meaning. So for me, there's no staging at the moment. Same game here again, getting the kube config. And if you go then to the task file, as you can see, I spawn the infrastructure. I register the Argo CD for Scaleway. I register the Argo CD for Linode. So as you see, he's using the current context, and add this via the CLI. That's the reason I make the Argo login before. And at the end, so let me start this quickly while it's explaining. So these are the tasks. And in my case, I started the control plane already. So what I will do now is just spawn the multi-cluster. So let us run this while we go through. So he will create now the infrastructure on Scaleway on Linode. He will then, when it's finished, register every cluster fully automatically to the control plane. And if this is finished, he will now deploy some applications. And this is also the second part. We talked about the apps of app pattern and the application set. So this is the infrastructure, and now we deploy the application, because we don't want to create in the UI something like create application and define my application there. So this is also as code. So if you go to the app of app pattern, again, the Terraform is just a Kubernetes deployment. So I I go to the YAML file, I deploy this, I use the kubeconfig, nothing fancy on this side. But here I say now, please create an Argo CD application. So this is the CRD of Argo CD from type application, and use this repository. So my main description of the application itself lies in a separate repository. So Argo CD knows now to create the application. You will see this optically. It makes absolutely sense if you see this visually. And everything what gets changed inside this repository, Argo CD picks it up and rolls it out to the clusters, to the specific cluster. And we go also into the description there to have an understanding what this app of app pattern is. But the main declaration of the main application is in the code and points to a code place, or could point to a Helm chart, for example. So Argo CD can also use Helm charts to deploy the application. So either in the Git repository or to a Helm chart and overwriting there the stuff. This is the app of app pattern description. So, and if we, it was clear that I did not open the app of apps. So, and let us take a look on how I described the app of apps pattern. There's also not something overly magic going on. So I point to this repository, and here Argo picks up and says, okay, there's a Git repository. Let us see if there are some technologies I already know. And here, for example, he detects a customization resource. Customization is a way to template, for example, Kubernetes deployments. I highly recommend to check customization. So you have vanilla Kubernetes manifest. You have customization, where you could use this vanilla manifest and make them ready for multi-stage deployment. You could patch specific values into it. Here, I use customization for some kind of gluing. So I say to customization, says, hey, the final deployment of the application consists from 2 different resources. You could have plenty of more. So you could go and say, I have a middleware, I have a key cloak, and so on. So there's really it's really up to your use case, no limit on this side. But in my case, I have a Hello server and I have a Grafana I want to deploy. So let us see how I described the Hello server and the Grafana. So now it gets really cool. So Hello server is again from type application. And here, and that's the thing with the classical application approach, if you don't use an application set, is you have really to write the cluster here inside. So you cannot, it's not possible to say, hey, wait, I want to deploy the Hello server to multi-clusters. Here it's really says, okay, it's just for one cluster. So here's the definition. That's the reason I wanted to show you also the application set, because this is the place where you do the multi-cluster deployment. And again, application, as we learned before, is an Argo CD resource. Some properties I can fill out. And here comes the important part to say, where is the stuff? And again, he goes to a Git repository. Here, for example, I have my chart saved. So I did not use Helm like artifact tab or something like this. I use again a Git repository because it's maybe it's a project my development team is working on and they have it in the Git repository. They work on this. I can say which revision they should take. So for example, say, okay, the Scaleway cluster is my development environment. Yeah, is my development environment. So you could, for example, deploy the master always like I did here, because you say everything what gets with a pull request, the main or the master branch gets deployed. If you would, for example, say, I have my Linode cluster, for example, is my prod environment. You could use also some kind of tag here. So in your process on your left side, you tagged the Git repository. You say, okay, this is the one I want to deploy. And then you could just tag the revision. So it's safe. And every time when nobody can touch this, and he will always deploy the target revision. But here it's the head. And here can automatically come changes. The Git repository, as I described before, the GitOps backend, as I described before, is keep constantly checking the Git repository for changes. And as soon he detects the changes, and on the main branch, this happens quite often because you do a development stuff, for example, he will roll out the application. Just one thing for the demonstration, I did not install now the part where you could check only the container changes. So here, if you don't change anything in the Helm chart, for example, in the values, you don't enter the version because you say, I don't want to make a pull request all the time. It's just the container who's changing. There is also a possibility every GitOps engine has this kind of container scanning, so they can go to your registry and check for changes here. But here in this case, it's for making it easy. So this is the Hello Server deployment. And here for the Grafana, I use a Helm chart, as you can see. So I say, hey, the repository URL for the source is this time is the GitHub page where the chart is saved. And here I say to him, and use the Grafana, not Loki or something else. I use the Grafana, and this is the version you're going to deploy. So that's the part. So this is the app of apps pattern. And when we go back here I defined it. So the application here defines another repository. Inside the repository, there are several sub applications. And the application set is now, oh, there are some questions. Okay. So the application set, as I said before, is specifically targeted to do this multi-cluster deployment. So there are specific generators. In this case, I use the cluster generator. I say to him, hey, deploy this application, here the Potato Head project, deploy this application to all the clusters where a label is set. In this case, it's just the label cluster. So he knows to deploy the Potato Head to the Scaleway and to the Linode clusters. But nobody is saying you cannot write, for example, staging tests. So all your, so it could be, and now this is the charm to say, okay, I have multiple clusters. And inside the multiple clusters, for example, I choose 2 or 3 clusters as my test cluster, for example. And when it's labeled with test, he will deploy this application, for example, to test. And here I could put some additional values in. I could say test, for example, goes always to head. And then I could create another application, Argo Cd application set for prod, for example. And this could be like hundreds of clusters, but I don't need to put them by name. He will go successively through them and apply them and says, hey, what is this cluster? Okay, this cluster is X. I will deploy the Potato Head with the version 1.0. So no need on this side. He will automatically do this part for me. So again, here you can really go absolutely crazy and say, okay, I make now some specific scenarios and say I deliver the application to these clusters because this is my test areas and so on. For us, for example, it's very interesting to say we have some stores, for example, in Lidl or Kaufland. We decided they are our test clusters and we want to deliver them our applications quite early. And the other ones are like a prod environment. So, and this is now when everything gets deployed. So you see Argo CD automatically picked up everything I described, I applied to the cluster because it's all Kubernetes resources. There's not something, some magic going on. So let us see the clusters again. Yeah, you see now he registered the Linode cluster. He registered the Scaleway cluster. You see the versions of the Kubernetes and everything is successful. I did not do anything on my side. So if I destroy it and restart it again, it will automatically pick up the stuff. And now you can imagine this list can grow immensely depending on your stuff. And he created also this umbrella applications for me. So here I have the app of apps pattern I explained to you. I voluntarily set the rollout on not automatically because I want to show you the difference here. And I created also this application set. And as you can see, if we go back to the application set, I said the application name you are going to create should be the cluster name minus potato head. Okay, so let us see. Yeah, he created a Linode cluster. That was the cluster name. And he added potato head. And you see the SCV cluster, everything automatically. So the templating engine of the application set is really helpful. And he iterates through all the available clusters depending on my label selectors and automatically create the stuff. And here, if we go back, I said to him and do automatically deployment. So make an automate. And as you can see, he automatically deployed the application. So here, let us go to the SWC cluster. I see all my resources. They are all managed here in the application. I see the deployments. The potato head project is microservice stuff. So you see every part of I will show you the UI. Every part of this potato head is our own microservice with its own image, and everything is deployed. So let us see how the application looks like. I don't create now an ingress because it will take too much time. But here again, I click on one of the resources. I can see also the events going on. Again, that's the reason we love it in the company, because the observability is really nice. Not everybody is a keyboard wizard and knows all the stuff. Makes really easy to see what's going on in my cluster. There's a health check, and I can see the Kubernetes resources. And here I can see I created a service of the type load balancer, so I get a public IP address. And if the demo gods are happy with me, we can go to 9,000. And here you see, this is the Mr. Potato Head in version 1. So these are the parts you see. Every part of Mr. Potato Head is our own microservice, and at the end it gets built in the UI. Okay, so that's one part. And let us go also to the Linode cluster, go also to the main part, and see, where are you? The public IP address of Linode. And the part is 9,000. Bang, there is Mr. Potato Head. So now there comes now the part and say, okay, how does it work now with the deployment? I mean, why does it detect automatically some changes? So I will go now to my GitHub page where I forked the Potato Head project. And let me open the Potato Head. This is here. And now somebody is working on a new version. There was a process before, depending on your company and your internal processes, somebody approved it, a manager, whoever the system is, and there were changes. So the microservice team for the Potato Head created a new version for the head, and the team around the right leg created also a new version. And imagine this could be your e-commerce, your web shop. So the recommendation engine team finished their service and so on. So everybody worked on this place. They created a new version. So I will do now not a pull request, please. Don't say your arguments are invalid because you push to master. It's just for the sake of the demo. So we do some updates, blah, blah, blah. And we push now directly into the master. So we push. And we go back to our system here. And as you see, he's still in an alt state. You can set the sync interval of Argo CD. So at the moment, I'm not sure how many minutes he will do the sporadic checks to see if there's some changes. At the moment, he's still stuck on this version. Let me see that I committed it. So, and this is the version 9.5. Okay. So we should see that the system gets updated. In this case, let me press quickly the read. Yeah, you see now he detected a change and he rolls out now the new. You see, he detected there's a GitOps change in the head. You see the new commit message, and you should see here, what did we say? The head was it? There should be now a new version of the head. So let us see, what did we enter for the image? Where are you? Yeah, you see here's now v2 written. So there is a change. I can see also the logs for Mr. Potato Head. So this is fine. Everything is healthy again. So this is automatically get rolled out. And because it's an application set, also you see the Scaleway and the Linode cluster, they are both in sync. They both detect the changes. They both reconcile the state in the Git repository, and both of them should now have a new left arm, and or was it head and right arm? I don't know. Right leg. So let us see if something changed here. Yeah. Now he has a head here and he has a head here, and see if Linode is doing the same. Yeah, that's fine. That's a real good stuff. So, and now I love to live on the edge. So now we decided, oh, that there was an error or something like this. We don't have some kind of deploy strategy or some rollout strategy. Let us go thing like somebody calls to you and says, hey, we have to roll back the stuff. Okay, so what can we do now? You could change here the versions again to say, yeah, make it back to v1. But I heard, and we talked also to different persons, and for example, they prefer also to use the git command. So here in the git rebase, I could now say, drop the last commit. This one was not good. So, and then we say git push. Okay, so now I hope I'm not screwed the system because I did not check this. Let us refresh. And you see, again, it's out of sync. He detected, and we are back to v1 leg. So in a perfect world, yeah, the system is both back again to the state. So this is the part for the application set. I handled now multiple clusters with ease, nothing to do on my side. I just go on the left with my Git flow, with my pull request flow. Everything is as code. That's quite easy. So this is the application set. And here on the apps of app pattern, let us see how this looks like. You see, you have now a thing to say, I have the main application. This main application consists of several sub-applications. They are not deployed at the moment, so let me deploy this and hope everything works fine. Here again, I did it manually because I wanted to show you that you can also say, okay, I start this thing here. I could make a dry run. Let me do a dry run before to see, is there an error? No, looks like he could deploy it back. He could deploy it without any issues. So living on the edge, let us synchronize the stuff. Okay, so instantly we get a problem. I will namespace hello Argo CD not found. Let me see. What did we create? Create namespace true. Namespace. Yeah, okay. This is, I will fix this. Okay, no problem. But he could deploy the Argo, and you see now the Grafana is popping up. And that's what I meant. If you are going to make deployments for multiple clusters, you keep repeating the stuff here quite voluntary. So you have to create another apps of app application and change, for example, the cluster. So you could have some things here quite getting the stuff only to do it by hand. And that's the reason they introduced now the application set controller to make life easier. and you don't need to have multiple umbrella applications to deploy, keep on deploying the same applications on the different clusters. Everything is now into one controller, so it makes life much more easier. But here, for example, so on the Scaleway cluster, Grafana gets deployed and should be normally, if what is the type? Load balancer again. So when we see the IP address of Grafana, it's the port should be 80. And we get our Grafana access. Of course, we can do the ingress and all the stuff. What was the Grafana default password? Default login. Default is admin. I forgot all the time. I have to check this. I think it was something like promtail admin and from yeah, whatever. So okay, at least the Grafana is there. That's what we saw, and it's deployed. So let us see what's the issue with my failed deployment for the hello server domain. I say to him he should deploy in the namespace hello Argo CD, but this one does not exist. So that was wrong from my side. So let us go to the apps of app pattern. File open Argo app of app. And we go to the hello server. And of course, it should be deployed in Argo CD because it's on our control plane. It's not on the Scaleway cluster, the namespace. It's the namespace on our Zero cluster of the control plane. So, and again, I want to go to the head. Let me check out the head. So, fix namespace. And let us push this to the namespace. Okay, so now it's pushed. And we should see when we click for refresh, we should see a change. Okay, and let us sync this. Again, a dry run. He says here, fix namespace. Okay, that should be fine. Fix, that was the main chart. This is the main, this is the subchart. So let us push again and say synchronize. Yeah, this time is much better. So he's deploying it. And let us see on the application page, here you see the hello server domain. And he rolls out every resource. And here's a crash. Okay, so what is the problem here? Okay, the image is not there. Maybe I accidentally deleted it in my GitHub account. Okay, but no problem. That's also good to see that there is now an issue and I can work now on this issue. And worst case, I roll back. As I said before, I can now roll back or fix the issue and make a forward commit. So that's also something we can do. Okay, that's it. And for example, yeah, that's the place here. Now we say we don't want anymore the stuff. So let me clean up my stuff. In this case, there's a change. I go back into my task file and I could now make a purge, for example, and say multi-cluster purge. So he deletes everything fine and neatly. And here you see now everything should be deleted in the best case. And you see he destroys also my applications. So that's completely fine. Okay, so let us go back into our slides. So we checked the app of app pattern. That was this side. We checked the multi-cluster deployment on this side. We see that we have now a nice feedback loop. We see that we can get all the information we need from our deployment. We can then decide if there is an issue, for example, how to handle this issue. You could create some automations on this issue with some kind of progressive delivery. You have also the possibility for this rollout strategy. So for example, in my case, the hello server domain was not working because the image was not there. You could say, okay, the old deployment is still working. So when you do, for example, the rolling update strategy, he will not now disrupt the current service. So you have a zero downtime possibility and can use this as you wish. Okay. Just one thing with the Argo CD. As I said before, that's a whole ecosystem about this. So Argo is a whole platform. So we have different possibilities from Argo workflow. What is a workflow engine? People use this also as CI, for example, like Tecton. They say, okay, hey, I can use the workflow engine also to build the image. So I can really do everything on Kubernetes, for example, to get rid of the pipeline on this start. CD. Argo rollout is that what I said to you. This is the part with the progressive delivery. So depending on metrics and the stuff, I could decide now to roll back automatically to a specific version before I do some canary releases on a large scale Azure events. So check this out. There's really much to detect and they keep coming up with new stuff. For example, the application set controller. Okay, so if we come to a conclusion, we saw now with the GitOps flow that we can reduce the amount of for example, manual work. In any case, we now have the possibility to let every cluster decide when is a change and roll out these changes on its own. So I don't have any security stuff to do. I don't need to create some agent on a CI system or create some secrets of a kube config and so on. So there's less possibilities for an attack vector. You know, in the recent time, the whole secure supply chain, supply tool chain subject is coming up. So people are aware of this. People know that a CI/CD pipeline could be a vector for some attacks. So we can reduce this and use, for example, this strategy to roll out our application or even build our application. So there's here the problem. But again, it's something new. You have to decide if it's something for your work, for your project, for your company. You have to create some atmosphere to do this. So your whole team has to adapt. You have to understand what you're going to do. There's still the problem, for example, with the secret management. So there are possibilities like Azure Vault or Bitnami sealed secret, where you can commit the secret also as a special encrypted to your Git repository with sealed secret. You could use a sidecar pattern or whatever with, for example, Azure Vault or HashiCorp Vault to say, okay, the secret is stored on another place. My deployment knows to go there to get the secret and inject it to my deployment, for example. So here, there are things you have to keep in mind. The worst thing you could do, for example, is to commit your configs with some passwords. So everybody knows an Oracle password, a Postgres password, or some certificates and so on. And you have to think about this. So there's always a shadow when there's sun, so there are some things, but in general speaking, it's a really interesting technology, and I highly suggest for everybody during a hackathon or something like this internally with the whole team, with the company, to investigate and see if it's something. But again, it doesn't mean that the classical way, the CI ops way, is obsolete. It's just another approach to tackle this. And there are projects, for example, now with Crossplane, and Azure is also doing some stuff, and I think Google also, where they say we do everything in Kubernetes, the whole provisioning, for example, of, you see, I use Terraform to provision the cluster. I could use the Civo cluster to provision via Kubernetes infrastructure from a cloud provider. And of course, I could take now this provisioning Kubernetes manifest and put them into the control plane in Crossplane, for example, installed on the Civo cluster. So I use Argo to make some pull requests to detect changes of the infrastructure, approve this, apply this to the cluster, and Argo picks up and Crossplane picks up any changes and do the changes on the infrastructure. So there's really much you can do. Okay, so any questions so far? I hope.
Yeah, Engin, if you look into the chat, we have a Google Docs there, and we have few questions there. I mean, like, you can share this.
Okay. Okay, so let us go to the question number one. How do we handle rollbacks? It really depends. Again, that's the nicest of all answers. It depends on the way you want to handle the stuff. So what some projects are doing is they do some forward commitment, so they don't roll back because maybe they have some database changes they already applied. I mean, you do the database changes to a managed service, and then you see that your backend application, your business logic is not starting. So what we do, for example, as a real life thing, is some projects do a forward deployment, so they fix it quickly and reapply the stuff. And we have a project, for example, they use Liquibase, for example, to manage also the database, to make it CI/CD ready, and they have also some possibilities to roll back the stuff. And then you can decide you want to make rolling updates, you want to make blue-green deployment, so you could have your services, all services still running. You deploy the exact application with the new stuff as a green deployment, for example. And then you just switch on the load balancer and say, okay, everything is working. I have to go. I have some tests. I have some metrics and whatever's going on. I'm completely, yeah, it works fine. So I just shut down the red environment, for example. We have also a project who do this on cluster side, for example. They really spawn a second cluster in Azure, and then they do the whole deployment of the application, all the changes there, and then they shut down the whole cluster just to have to mitigate these problems. So, and worst case, as you saw, what I did is I just deleted, for example, the Git the history. I just deleted and the system detects and roll back. But again, it's only possible when the managed services you consume or any states you change are not affected of this. About the feasibility of using workflow for the cluster already in Turnkey. Yeah, this is something you can do. You can say, okay, which applications I have at the moment, which services I deploy there, and say, okay, let us take out some of the services or application and deploy them via the GitOps way. So install, for example, Flux. If you say, I don't want so invasive, I don't need a UI, for example, we are quite good. Our SRE team or our ops team knows very well to handle also the resources, also with K9S or something like this, and or you have your logging all in place and your monitoring, everything works fine. Then start to find out which projects you want to cut out and deliver via the GitOps flow, and see if you want to create a GitOps a Helm chart for it, or you want to use the vanilla manifest if you want to use customize. So it's really up to your project and the way you want to tackle this transformation. Again, what we did, for example, is that most of the new applications get delivered via GitOps, and the old applications stay like this. Argo is completely stateless. Argo has, for example, a Redis and all the stuff. So there are some informations he's saving, but mostly he used the CRD in the background. And for me, for example, I don't use the Redis part. So he has also some kind of rollback mechanism you see, but this is something I don't use. I use always the Git part. So I'm not relying too much on Argo CD. Again, I don't want to build Argo CD and the UI of Argo CD as a new point and get used to it, because I say, okay, actually it's all my my Git repository. Can we add Argo under the auto scaling group? I don't get this question. So
yeah, if anyone wants to unmute their mic and maybe ask the question, it would be great. Yeah.
It's just Kubernetes resources here. So you could use every Kubernetes resource you could do. So you could, for Argo itself, you could set a replica set, for example. I don't know if the Helm chart of Argo CD has also some kind of pod auto scaling, for example. I have to check this to see if you can, because it has also different parts of it, but of your main applications, you can use every Kubernetes resource. It's all about Kubernetes. So a pod autoscaler, node autoscaler, everything should be horizontal or vertical. If it's enabled in your cluster, it should be no problem to also roll out the stuff.
Yeah, and like I would like to do a follow-up question on that. So while deploying Argo CD, since it's our source of truth for, not the source of truth, but the point, like who will be responsible for deploying change across multiple clusters, multiple environments, right? So how about the high availability of that thing itself? Like I've digged a little bit into Argo CD, like and how do you ensure that Argo CD doesn't go, I mean, it doesn't crash? Or do you have any suggestion around like the high availability deployment of Argo CD itself?
Yeah, okay, then it makes sense. Yeah, you can deploy everything as a high availability. Even Argo itself says if this is some requirement, for example, you can deploy the Redis in a HA scenario, so you can really pimp your Argo CD. As you see, what I built now is a hub and spoke architecture. So I have the central Argo CD, and you can do it. I mean, just check the Argo CD Helm chart and see what you're going to do and what you want to do. But yeah, the Redis and everything, it's with a high replica set, and you can say even I make some node placement to say, okay, I have dedicated nodes where only Argo CD is running, or you say I have data center. So if you pump up the replica set of the Argo server, for example, you can say, please place the replicas into specific data centers in Azure, for example. You can do this. So there's possibility. For example, when we used Rancher and Fleet, we did this. We created the Rancher instance with 3 replicas and said that every pod should run in his own data center to avoid any issues in a data center. So yeah. Okay. And this question, we have also people in our company also says, who's responsible for Argo CD? There's also Argo CD operator. So you can check also the operator. I don't know which level the operator has. So if you go to operator hub, we can see if he's on autopilot. So if we go to Argo, here's the Argo CD. You see the operator is quite mature. It has autopilot on. So it means it can horizontal, vertically scaling. It detects, I mean, that's really a nice maturity. So if you are like, okay, I want to deploy it as an operator, I would go this way. So in this demo, I just deployed this Helm chart, but yeah.
Yeah, I was thinking of creating something like different cluster, like a DevOps cluster, where I'll put all those management stuffs, usually logging, other like error reporting things. I was planning to put Argo there, so Argo will make deployments across multiple environments, multiple clusters. Um,
Yeah,
okay, I'll look the docs for
yeah,
have looked here. Okay, thanks.
yeah. Oh, that's really cool. I mean, it sounds really like a good project you're going to work on. That's much fun. And as you see, it's this whole multi-cluster thing getting more and more real. And yeah, I think you are ready with the hub and spoke also if you want to use Argo Cd, of course. So that's fine. The distribution of the traffic, is it for Argo? Is it for the applications you want to do? I mean, it's up to your service. I mean, you can set the traffic there. I mean, it's really up to you how you want to split the traffic and your deploy strategy on your service, on your Kubernetes service. I mean, that's not something Argo is limiting there or something like this. This is up to you. Or maybe you have a gateway, for example, you want to do the stuff on the gateway side. On the service side, I mean, there are really plenty of possibilities. Or on the ingress controller, you can do this. In the demo, you made manual changes to Potato Head. In the real world, this changes you do with a pull request, for example. So, for example, the Helm chart you saw for the Potato Head, there would be, for example, some process. Some people did the change and there's a release process. Maybe it's automatically that a pipeline is also pushing into the GitHub, into the Git repository and saying, update the version, for example. And there would be a process depending on your software development culture in the company, either full automatically or semi-automatic with a pull request. It really depends on how you want to proceed this. As I said, also you had the possibility for the dev environment, for example, to use the image updater. So there is the Argo Cd image updater. And here, no, it's not here. It's there is the chart. Okay, read the docs. And here you have the possibility to also automatically update the image. So the cluster itself, where is it? Scans your repository for some version changings and automatically deploys it if only your container is changing. This is, for example, something we do for the dev cluster because people keep on committing stuff and so on, and they don't want to go in and add some kind of build number to the Helm chart or whatever. So they say, okay, I create all the time some versions and I want that Argo is automatically deploying this. So install the image updater, point to your repository. So point to your container registries, supporting different container registries, and then he's automatically scanning this and rolling out stuff. But for me, it makes sense in a development environment. And the image updater has also the possibility that he can update the Git repository if there's a new image available. He detects the image and he could update your Git repository. So please check this out. This is really also an interesting project, and it's very fun. I use it only in the dev environment, as I said, to avoid all the time making some pull requests for a build number change for the dev environment. Flux has also an image updater. This is something common because, yeah.
Yeah, and like that's also a question from me, and I was thinking of writing, I mean, replacing my current CD process. I mean, where I usually apply the Helm chart directly from my CI server. So I was thinking of, okay, the CD part, it would be offloaded to Argo, and the CI part, like whenever the image is ready, it's supposed to the image repository. So the CD part now, what it does is it just do another commit to the Helm chart repository. So I think I'm trying to like do what this image updater is doing behind the scenes. So
Yeah.
I was following that way.
Yep, that's completely fine. I mean, as I said, I mean, that doesn't, if the system on your side is perfectly, I mean, and you say, okay, I did all the tests, I'm sure, okay, and now I make the Git push also from my CI system for the values for the dev environment, then it's completely fine. But there's only one thing you have to keep in mind, and this is the reason, and I want to show this also, the latest ThoughtWorks radar on GitOps. And what this colleagues did from ThoughtWorks of the radar is they put GitOps on a hold, not because the technology or the way is wrong. They fear that you come up with branches by branches by environment. So whatever you're doing now with your new transformation, don't do branches per environment. So come up with the values, for example. So like the 12 factor is also saying, inject the stuff from external for the different stages as a config, as a value, for example, but don't come up with branches for per environment, and then you're good to go. So that's really one thing to keep in mind. Otherwise, you end up in this problems, and it's something I can highly stress to avoid this, especially if you start now, because it's the logical thing people always think about to say, okay, I have a branch called dev, I have a branch called prod, and they have the stuff. No, don't do it. I mean, use the values of the, for example, 12 factor app. Keep this in mind, and then you can say, okay, everything gets injected as a config, for example, to store my config for the specific environment. So just from my side. Okay. So
maybe we can have some open mic session if somebody wants to just unmute and ask. Otherwise, I have still few questions, but I'd like to let other people ask. Okay, maybe I should ask while waiting. So yeah, for the schema migration, do you suggest the GitOps flow like this? I mean, like trying with Argo. I mean, do you have prior experience or some, I don't know, some possible, yeah, I mean, bad times with Argo applying migration, DB migration? Is it a good idea?
The schema you mean for databases?
Yeah, the schema migration for the database.
Yeah, I mean, as I said, you can try to get your description of the database in a system like Liquibase, for example, and then you have everything there, and then you can say, okay, I have also some changes in the database, in the schemas or whatever. It's also as a code, and I have also the rollback possibilities. And this is something we say, but again, it's a difficult subject with this database stuff. There are different approaches to make schema changes, maybe over several iterations to say, okay, I don't drop the table. I let the column, for example, or the stuff, I let it there. Maybe I make a view or something like this, and I do it in small steps. So I don't have a big bang stuff and so on. It's really, I mean, either as a Liquibase, getting the stuff there, and then you have rollback and also the changes, or doing changes in little increments and having the possibility to roll back at least one or two versions without any issue. And then you say, okay, I support in my database the last two versions, for example. So if one version is using a specific column, I don't deprecate this, for example, or I don't delete it immediately. So I can still move a little bit there. But or like my colleagues did, they just say, okay, we go forward. When there's a problem, we will not roll back. We will do the changes immediately and keep on pushing and changing until it works. I mean, that's also an approach.
Yeah, so you have to maintain those, backward compatibility while you are making those changes.
Yeah. And then have to think about maybe making some changes. Okay, maybe the whole architecture is not ready for. Maybe we need to do also changes there to say, is this still valid now in this place? We saw the last 5 times. We have massive changes in the schema. Is this still the right technology, or should we look out for another way handling this stuff, having some kind of eventing, some kind of messaging between maybe, or using some other technology, for example, could also be possibilities to handle this stuff, because then it means there is some issue and it's worth to spend some time into it.
All right. Yeah. Thanks, Engin.
Yeah.
Okay. So anybody have any questions or queries or anything to add? Okay, one question from my side. So can we use Argo CD way to upgrade the Argo CD version, or we have to use a different approach for that?
For this, I mean, yeah, you could go to the Terraform like I did and change the version, and the Kubernetes cluster will use, for example, rolling update to change the stuff. I mean, it's the way to do this, or you could use the controller. I never. There is one project called the Argo Bootstrap CLI who uses Argo to manage Argo, but I'm not. Let me share you the screen. Yankee noticed because I added this to what is named to Arcade. So it's the Argo CD out Bootstrap CLI. I forgot the name. What was the project? Argo CD Autopilot. Yeah, so this is the Argo CD Autopilot, and you can try this out because he do everything and handles Argo CD inside Argo CD. So you will see in Argo CD the Argo CD deployment resources also available, and then we can handle probably also an update from Argo CD in Argo CD. But that's a good point. I need to put this into the slide. So
yeah, can you add also? Yeah, maybe on the slide or on the doc.
So okay, this
okay. Yeah, we have that learning resource tab in there. Yeah, there.
Well, that's okay. I think you
no,
will.
I'll just manage that. Okay.
Okay. So. Okay. So.
Okay. So anybody have any extra questions or any experience you want to share if you are working with the Argo CD or any of those GitOps platforms? Okay, so I think nobody wants to talk. So anyway, so thank you, Engin, for your time, for sharing this wonderful resource. So I'm sure like this will be way helpful, and we'll be uploading this recording on our YouTube channel also, so that those who cannot attend can also get the idea and just go through the session. So once again, thank you all. Thank you, Engin, for your time, and thank you all for joining, and stay tuned. And we are having another meetup after the same. I think that will be on 24th of October. So it will be about vulnerability scanning on a larger enterprise. So I think that will be between Dasai and TR, because Engin we are having a festive season. So after I think 2 weeks, we are having 1.5 week of festive days. So we'll be totally out of laptop maybe. So we'll be having another session after that. Yeah, okay. So thank you all, and stay healthy, stay happy, and keep on learning. Bye bye.
Bye. Thanks.